So as we saw yesterday, we had when we came down here with Josh, we had the YSI, and you know, we were able to get a lot of readings from that. However, we did kind of find out that also comes at a price point, having that instant, you know, you dip the YSI in and you know all the way, you know right away your 4 or 5 different readings, and it comes at quite a high price point. So there are other options that you can do to. So basically, right now what we're going to be doing is we're going to be looking at some of the more labor intensive, essentially, ways of figuring out, well, what's the DO, what's the pH, what's the turbidity in the stream, and then we will compare that to the YSI to kind of show that, or to see how accurate are they, and to show that they're still, you know, accurate enough for you to identify any possible issues in the stream, in case you don't want to spend $5,000 on a probe or on a YSI. Okay, so we'll come over here. We have these the Lamont kit here, or we'll start with the Fox kit. So these are different kits that are used among a lot of the stream keepers in all over BC, basically. And this is this specific one here is the dissolved oxygen kit. And it pretty much, it comes with instructions on how to use it. So it's always, you know, want to keep these with it. It's relatively easy to use with just a few different solvents that you want to include in the water to then help you read it. So you have all your different products here. So why don't we'll start off with this, and if I can get one of you to, we'll use this pool here to go down, and so it is made out of glass, so just don't drop it anywhere. Go down, and if you can get get water in here to be
I'm the only one with boots on.
from about halfway up the water column, and just kind of hold it in there for maybe 30-40.
Halfway up there.
You can go right on here, but just don't just get the surface water, get the water. Yeah, I've done this last time. I'm just gonna refer to this a little bit. Yeah, they're always fun to do because you actually get to do some. You get to feel like a scientist with mixing a bunch of stuff together. Yeah. So you want it all the way full. All right, so we have this. So next, we're basically, what you want to do is you want to just kind of like fill this up to, and it's going to fill a little bit, but you want to make sure that there's no air bubbles in here when you drop it in. So it was full enough, so we're good with that. Sorry? Well, because those air bubbles will increase the oxygen content. So you really just want to know what oxygen is in the water, right? So next thing what we're going to do is, there's these different reagents here, and as you can see, so this one says oxygen 1, oxygen 2. So it's all labeled. It's very almost foolproof. But you want to add they're kind of hard to open, so you add your first one. Put that one in. And we can all do this. We have 2 kits, so once we're done with this, everybody can kind of like give us a try.
So you use what over?
You do, yes. So you use 1 and 2. You put those in, and then next, what you want to do is, after you have those in there, you want to make sure that you put that stopper in again without any oxygen, and then you want to hold it kind of nice. So the stopper as well as that, and then just kind of shake it a few times to really mix it up in there.
Okay.
And then we let it sit and we wait. And if it starts to kind of get cloudy, that's a good sign. That shows that there is oxygen in it. It already kind of starts working. So we'll just wait a little bit. And in the meantime, you can kind of get your next reagents ready. So this is the reagent 3. If you look at the instructions, they start talking about reagent 3. So just get that ready. And one thing is, Taylor, in one of those totes, we have the bottle. So it's always, you don't want to be pouring the liquids once you're done necessarily back into the stream. It is chemicals. Now, that being said, not actually that harmful in the end. But again, we don't really want to do that around the stream, right? So if you have a rain garden at home or something, you can do it there, or possibly, I'm sure the sewage plant receives worse, so possibly get it down the toilet. Yeah, so we have this bottle here that we just collect everything in and get rid of it every now and then. All right, so you can kind of see how it's already separated there. So what we want to do is we can mix it up again another time, and then start getting our next reagent ready. It's good to have a knife or nail clippers because these things are pretty tough to open. All right. So now I pour this in. Try to get as much in there as I can. Okay, so now I drop that again. Try to get no air bubbles. Ooh, there we go. And then gonna shake it up again, and we wait again a little bit. A little bit of waiting involved in this part. You can see how the YSI is a lot quicker and, you know, kind of nicer that way, but that's also costs a lot more. So
we already have an oxygen meter.
Perfect. That's even easier.
So we've just gone to get it. So we're going to compare.
We can compare the three of them.
Okay.
Yeah. So just basically fill this up to the rim there. You can do it over this, and if you spill some, then it will go into here.
Can I leave it there?
Yes, that's okay. All the way to the top. Perfect. So now you can put that into there. Oh,
sorry.
Yeah.
I thought it was like a cuvette.
Sorry?
I thought it was like a cuvette, like you pour.
Oh. All right, so this next step here now, what you basically want to do is, you see this, so you see that it has kind of a yellowy tinge to it. I'm just going to hold the white paper behind it. So we're going to add these drops into there, and you want to count how many drops you add in until this is clear. So until it's crystal clear. So yeah, so 1 drop, swirl it a little bit. 2, swirl it. 3, 4, I'm guessing 11. 5, 6. So it's starting to get a lot clearer, you can see, right?
Maybe you should put something white
7.
behind you. So then
Yeah, we're almost, it's still kind of yellowish. 8.
I think almost. But
Almost. 9.
Oh,
How's that? Did that change?
Yeah, no, it's pretty
If
clear.
it changed, then we'll do one more. Has that changed? Did that change anything? No?
No, it's
Okay,
pretty
so
clear.
10. So that was 10 drops. So now what you do is, on here, that you have on this graph here, and at the top, so we said 10 drops. So you take a pencil or a ruler, like something with a straight line essentially. You hold it at the 10 mark, and that is, so that was 10 milligrams per liter, which is 100%. So then what you then do is you take that, so it's 100% saturated oxygen in the water here. So you can see here on here, so 100% saturated oxygen is right there. So your Q value, which goes into this table, the Q value would be 100% saturated, would be I guess it's not exactly at 100, it's probably at 99. So your Q value goes into there.
99?
Yeah.
Is it good?
Oh yes, 99.
Yeah.
Is it good?
That's good. Yeah, it's very oxygenated there. Get in percentage, right?
Yeah. So I wonder how we convert it.
I think you would have to do a conversion with the temperature, like Josh was saying.
Also, this said it was 14.4 degrees C, but this could need calibrating.
Was yesterday? 7.8.
So this will be more oxygenated right at the end of the year.
Should be, yeah.
After I calibrated it, someone write these two numbers down for me.
Go ahead.
10.2 parts per million O2, 98% saturation, and it's 13.4 degrees C.
So the last one?
13.3 degrees C.
Perfect. Thank you. Okay, so for the pH here, what we're gonna do is we got the creek water, and we're gonna add 10 drops of this indicator in there.
You come over later and do my pool water.
So yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close it up. Mix it up. And then we have this really fancy meter here that you eat, right? Yeah, we know that, you know, it was 7.8 yesterday, so there's basically one of these here. This one goes from 3 to 6.5, and then this one does 7.5 to 10.5. So I know, you know, from historic data, I know it should be somewhere on here. So with this kit, what you do is you put it in there, and then you want to hold a white background behind it and try to compare the colors. It's very simple, and so we can pass this around and then see what you think it might be.
I'm saying
9.
7.5.
No.
5?
No.
What do you think?
It's here.
9. You're in the 9 range.
Yeah, 9.
You think 9?
7.5 was the popular.
Okay, so up here, so then up here in the pH reading, we put 7.5. 7.5. Then in the pH reading down here, the result, you write your 7.5. For your Q value, you go back to the pH graph, and down here on the pH units, you go to 7.5. So that is 92, 93 Q value probably. So let's just call it 92. So your Q value is 92. The whole Q value thing will make sense once we do the calculations. So right now for your dissolved oxygen, your result is 10. Your Q value is 99. pH result is 7.5. Q value is 92. So now we go to turbidity. Okay, so we have two different ways to look at the turbidity here. The first one is with this turbidity test kit here, which we'll use first, and then we'll show you the other way. And basically what I need is, I need some water again. So to the 50 milliliter mark there.
1 millimeter?
50. So you want one of them adds your creek water, and the other one you want water that you know is clear. So this is water, I think it's out of the tap, or it's bottled water, one of the two, but I know it's clear. So I fill this up to 50 with this water as well.
This is quick water.
Perfect, that's creek water. So if you look from the top down, you can all come here and look from the top down. You can see the difference in the colors. With
Right, it's almost same, but from the
top down, it's very different, right? As you can see, it says like 5 milliliters, 0.5 milliliters. You take that and you put that into here, and then we swirl it around, and we see, is the water now the same turbidity or not? If the creek water is still more turbid, then sorry, you put it into this one, into the clear water. If the creek water is more turbid, you add more. So essentially you're adding turbidity to the clear water.
Oh,
So do you want to try that? So how does that look? Turbidity wise? And remember, we're not looking necessarily for color, we're looking for the turbidity, right? So
okay.
I would say,
the black
Are you
dot
the
may
same?
become blurry, or is that what you're saying?
yes, so you're concentrating on the black dots, not necessarily on the color of the water. So you're trying to find how clear is the black dot, like how visible. So I think we probably
very
want to add
visible,
another
yeah.
one.
So it makes blue.
Yeah, so then you look through the black dot and then you see like if it's how clear it is compared to the other one.
Yeah,
You
like
see-
I would say that's pretty close if you want to take a look.
What color?
Another color, yes.
Yeah.
Blue, blue,
Just,
yes.
just how clear the black
Yeah.
dot looks. Yeah,
It's pretty close, right?
yeah. If anything,
A little too much, maybe.
this is too much.
Yeah, so it's probably right in between that. So we added 2 of those. So the 2 goes here in the results. And then you go to your sorry, I skipped a step. So on here, 2 of the measurements at 50 milliliters are 10 JTUs. So we had 50 milliliters of liquid. So we added 10 JTUs. So the result is 10. You go to your turbidity graph. You find the JTUs, which is the lower number, and that is at 10. So you go up. So your Q value is probably 75.